So for chapter 7, we talked about confidence intervals, which are used to predict the average for the population. So remember that you have a formula that is going to look like this. Okay, I would definitely make sure that you have that written down with your chapter 7 material. Make sure that you have your z-scores, 1.65, 1.96, 2.58 for the different confidence intervals. So that you don't have to calculate those on the test, that you'll have them and you can look them up. So make sure that you've got your formula handy for a confidence interval problem. Remember that we do have the option of replacing this z-score right here and right here with a t-value. And so you want to be sure that you are clear on when to use a z and when to do a t on these problems. So remember that it really comes down to your standard deviation. If you are given the standard deviation of the population, then the problem should be worked with a z value. If you are given the standard deviation of the sample, then the problem should be worked with a t value. All right, and so you do have to read through the problem and make that distinction. Is it population or sample for standard deviation, so that you know which formula to use. All right, so let's just look at an example just to kind of remind you of how this is going to work. All right, so this one says a principal wants to estimate the average number of hours that students study each week. The standard deviation from a previous study. Okay, so remember that if it's talking about a previous study, that is an indication that we have the population standard deviation. Okay, so I know right now, I'm just making myself a note so I don't forget. Population standard deviation is 2.6. This also tells me right now that I'm using a z-score in the formula. All right, the principal surveys 45 students and finds that the mean is 8.7. Find the 99% confidence interval for the population mean. All right, so I know that he surveys 45 students, so that's my n value. He finds that the mean is 8.7, so that's my x bar. 99% confidence for the z-score would be 2.58. Okay, and we know the standard deviation of the population is 2.6. So we have everything we need. We really just need to plug into that formula. So remember that your formula, I'm not going to rewrite the formula here, but you start off with the x bar, you subtract your z-score, and then in a set of parentheses, you do the standard deviation divided by the square root of n. All right, and then on the other side of the inequality, you do exactly the same thing, but you put a plus sign. All right, and then you can go to your calculator and type that in and get an answer for both sides. All right, so on the left side, I get 7.70. And on the right side, I get 9.70. Okay, all right, so that's an example of a z-score problem. Let's go ahead and look at one more with a t-value to be sure that we can do that type. All right, okay, so this one says for a group of 20 students taking a final exam. All right, so let me just kind of write down as we go. So that would be the n value. The mean heart rate, so that's the sample mean, is 96 beats per minute, and the standard deviation was 5. So remember, if the standard deviation is referring back to those 20 students, then it's sample standard deviation. Okay, so sample standard deviation is going to be 5. So this tells me right now that I'm going to be using a t-score in the problem. All right, and I'm going to have to find that t-value. All right, so let's go ahead and set up as much as we can, and then we'll find our t-value. So x bar is first, so that's going to be the 96. All right, and then I'm going to be plugging in this t-score in just a second when I find it. And then I have my standard deviation on top and the square root of my sample size on the bottom. Okay, so pretty easy setup here, especially if you're looking at your formula. And so the only thing now that we need to do is go to our table and find our t-score. Okay, so we are doing a confidence interval, and it is 99%, so we're going to need that. And we have a sample size of 20. All right, so I'm going to go back to my table for just a second. All right, so we said 99%, and we said sample size of 20. All right, so remember this DF column, when we are doing confidence intervals, is sample size minus 1. Now this can be confusing because remember that in chapter 10, when we do the regression analysis, it's n minus 2. But right now, with the confidence intervals, n minus 1. So I'm going to be looking at 19, and on the confidence interval row across the top, I'm going to be looking at 99%, which is going to be way over here. You guys can reference your table from the copy that you have. But 99% is going to be way over there, and I'm going to be intersecting that row and that 99% column that's going to come in right here. All right, and let me find that value on my table, and then we're going to go plug it in. All right. So you guys can grab your table there and make sure that you can find it as well. All right, 19 and 99%. All right, gives me 2.861. So that's the value that we want, 2.861. So I'm going to go back and plug it in, 2.861. All right, and then we'll go to our calculator and type it in. All right, so on the left-hand side, I'm going to get 92.80. And on the right-hand side, I'm going to get 99.2 when I round it. Okay, so that is a quick review of Chapter 7. Again, be sure you have your formula written down. Be sure you have your z-score confidence, z alpha over 2 values. Be sure you have both the tables handy as you're working these problems. Watch for a problem that says confidence intervals. That's kind of a key phrasing to using that formula.